So after the types of the queue, if we come to the operations of the queue, this is also one 5 marks question. Operations of the queue. See, Q, NQ, GQ, size and is empty. Size and is empty are the operations of the queue. Just meaning of these types of the operations. Q, as the definition says, a normal Q definition, adding of a new element and inserting of a new element at two different ends, adding at rear end, deleting at front end, this is what we call as Q. Then NQ, adding a new element to the existing queue. DQ, deleting an element from the queue. And size, total number of elements inside the queue. And is empty, whether the queue is empty or not. By the operations of these queue, now we are going for the two important algorithms that are NQ and DQ. That means adding of a new element to the queue and deleting of an element from the existing queue. Then let us discuss about algorithms. If we are coming to the algorithms of the queue, NQ and DQ. NQ means inserting of a new element and DQ means deleting of an element from the queue. So if I come into the algorithm, step number 1, same as we discussed earlier, like a stack and insertion and deletion, same method we are also using same. If rear is equals to n, if rear is equals to n means that queue is full. For example, this is one kind of the queue. Okay, all the elements are full. All the elements are full in this type of the queue. That is equals to rear is equals to n. Rear is equal to n means queue is in a full. Okay, exit and end of the if statement. If already the queue is full, we don't have a chance to add a new element to the queue. So here there is no chance to add a new element to the queue because already the queue is full. But when we have a chance to add a new element to the queue, it minimum contains a one blank element. So if front is equals to null, if front is equals to null means here there is no element. No element means now the queue is empty. Now the queue is empty. That time, yes, we have a chance to add a new element. That's why the condition, step 5, front is equals to 0, rear is equals to 0. Means this indicates this queue is empty. Here there is no element. Here there is no element in the queue. Yes. If this condition is true, false, yes, rear is equals to rear plus 1. Rear is equals to rear plus 1 means adding a new element to the queue. Rear is equals to rear plus 1. End of if queue is equals to rear, a new item is added at the rear end. That is what we call as a new element is added. For example, front is 0, rear is also 0 means now that queue is empty. Now adding of new element 10 comes to this position like this. Now the 10 is added. This is the 10 element adding by the rear end. That is equals to rear plus 1 and q of rear is equals to item is equals to 10. Now the new element is added. That is what we call as 10. Before inserting in this particular queue, the total number of elements that are 0. Now after inserting a new element adding a new element to this queue, that a total number of elements, that is 1. So this is what we call as NQ, inserting a new element to the queue. Then if I come into the DQ, see the condition is same. If front is equals to null, means this is one empty queue. Front is equals to null. Here there is no element. No element means yes, print queue is an empty. Empty means underflow condition. So without any element, how you will delete an element? So that's not possible, right? So print queue is an empty. Then exit end of if this condition is closed. From this condition, what you are understanding? If you want to delete an element, minimum one element must present. Correct? So item is equals to queue of friend. Now the concept will begins. If you want to delete an element in the queue, which end you will choose? That is the friend end. So item is equals to queue of friend condition. If friend is equals to rare. If friend is equals to rare means, here the last point there is no element. Friend is equals to 0, rare is also 0. Now we don't have a chance to delete. Else, another condition, if it is false, friend is equals to friend plus 1. Friend plus 1 means here one element is present. Yes, now I have a chance to delete the element 10 from the friend end. Yes, of course, 10 will be the one element I am removing with the element that is end, that is friend end. That is the condition. Friend is equals to friend plus 1. Friend plus 1. So now the element 10 we are deleting. So this is what we called as a deletion of an element from the queue. Very important algorithms: insertion or NQ, deletion or DQ. Don't confuse with the concepts with insertion, deletion with array. That is a different concept, and queue is a different concept. Adding of new element to the queue, that is NQ. Deleting of an element from the queue, that is DQ. So these two are the algorithms. They may ask individually for 5 marks. After applications of the queue. This is also one 5 marks question. So after the algorithms of the queue, NQ and DQ, now we are coming to the last concept in the queue, that is applications of the queue. Where we are using the queues. See one by one. Printer server routing. Printer server routing means if you have a knowledge about a printer and setup and its configuration, for printer server, a series of computers are there. We have to set one printer for the computer, and that will be acting as a server printer that will be connected with one computer. If any series of operations will come, during that computer will connect to the printer and print will be established. So printer server routing, because queue will be processed one after another, documents will be printed. If you have a knowledge about some browsing centers in the cities, their series of the computers are connected to the one server, server computer, and that server computer is connected with the printers. See, some 10 users are there, means 10 users also have a chance to use the print. But how the print will come? That will be in order, queue, first in, first out. Which user will give the first print, then the server will accept the printing and it gives the print. So this is what the format, server printers and the setup of the server routing. And multi-programming, of course. With the help of the queue, the programming, more than 2 programmings also have performed with one after another queue. And also CPU scheduling. CPU scheduling means sometimes for the computers we need a automatic restart. Sometimes we need a schedule on and off, restart, shut down, turn off, turn on. We need with the time scheduling. Automatically the computers will on, automatically the computer should off, sometimes after completion of the work. So some situations will come like that. On that time, these queues will help to scheduling of on and off of the computer. That is what we called as CPU scheduling. And round robin system. Round robin system is a type of the technique we are using one after another, the solving of a problem. That is what we called as round robin system. Simulations. Simulations means adding a new technological aspects to the one after another. So that is what we called as simulation. And also process of the operating system. Operating systems also will follow the queue, because one task will be completed after another task will be begin, means that should complete the first initial task and later that will go to the next task. That is what we called as a process. So this is what we called as a process of the operating system. All these are the applications of the queue. This is for 5 marks. Now we are going for one more data structure that is very important, linked list. So after the data structure queue, now we are going to one more final linear data structure, that is what we called as linked list. So as the definition says, linked list is a linear collections of the data items called nodes. Remember the keyword. Collections of the data items called nodes. Each node is referred by means of pointers. Means you know the pointer concept, it will stores the address of another element locations. So that is what we call as pointer. So here linked list is a collection, linear collection of data items called node. Each node is referred by means of the pointer. So this is the definitions of the linked list. And also linked list uses always dynamic memory allocation. So you know the concept of memory allocation, static and dynamic memory allocation. Static means a fixed type of the memory allocation. Dynamic means continuously changes memory allocation. Here fixed size of the data items, here chance to change the number of sizes, and wastage of memory will occur at the static. There is no wastage of memory allocations during the dynamic memory allocation. And also these are all some classifications, the differences between static and dynamic memory allocation. But usually linked list will follow the dynamic memory allocation, hence we have a chance of lot of advantages compared to all previous data structures. Then we have some types of the linked list. So in that one, if I classify the types of linked list, in that the first one is simple linked list. That means SLL. Second one, circular linked list. That is CLL. And third one, double-ended linked list. That is DLL. These three are the classifications of the linked list. Simple linked list SLL, circular linked list CLL, and double-ended linked list, that is DLL. Now let us see the definitions of individual linked list with the diagrams. So if I coming to the types of the linked list, singly linked list SLL, circular linked list CLL, and third one doubly linked list DLL. So if I coming to the first one, SLL, singly linked list. So here a simple linked list definition. Linked list is collections of linear data items. Means with the help of the nodes, these data items are connected internally. So that is what we call as a singly linked list. See here the three components are there, three elements are there, 10, 20, 30, and each element is containing with a node, and with the connecting node P1, connected element is 20, with the P2, the connected element is 30. Like that, this is a single linked list and ended by with the null that indicates the queue is closed now. So starting and null point, if it is defined, that indicates in this type of the linked list, three elements are present and that should be ended. And if I come into the circular linked list, CLL, so here the last element node 30, the P1 node is directly connected to the first node of the element 10. So this is what we call as a circular linked list. The last node of the element, is 30 and the noded element is P1, that is connected to the circular path, that is in a closed circuit with the first element 10 with the P3. So this is what we call as a circular linked list, CLL. And final one, double linked list, the starting and null points are indicated. Each elements are connected with the two different nodes, that are what we call as a doubly linked list. At both ends, insertion and deletions will occur. So that is what we call as doubly linked list. So this is what we call as a types of linked list. Some for examination they asked so many times, write the types of the linked list with representations of the diagram. After this we are going for some operations of the linked list. So these are all the common operations what we discussed for the non-linear data structure. Same operations we discussed for the linked list also. Some list of the operations: create, insert, delete, searching and sorting. Creating a new type of the linked list. Insert, adding a new element to the linked list. Delete, removing an element from the linked list. Searching, finding an element and its location. Sorting, arrangement of elements either in ascending or descending. These are all the operations of the linked list. Once again I will repeat: create a new linked list. Insert, adding a new element to the linked list. Delete, removing an element from the linked list. Searching, finding an element and its location. Sorting, arrangement of elements with ascending or descending manner. These are all the sub operations of linked list. Here afterwards you have some algorithms, but for your syllabus, as per previous year history, as per our experience, no need to learn about some algorithms. So, but we have some algorithms, nearly insert, delete at two different ends, beginning and end, like that. We have some algorithms, but if you learn operations, types of linked list, definition, and with some diagrammatical representation, that's more than enough for the linked list. Now, the non-linear data structures will come. In that trees and graphs we are going to learn about. Okay. So finally, in the data structures, non-linear data structures, as the definition says, a data structure in which each node is connected with several other nodes, So, some examples are trees and graphs are the two non-linear data structures. According to the definition, data structure in which each node is connected with several nodes. So that is what we call as non-linear data structure. Here there is no homogeneity, here there is no continuous connections. But here the connection is there, but with the different manner. So that is what we call as non-linear data structure. Let us discuss about some trees and graphs, diagrams. Now we will get some idea about the non-linear data structures. First we are going for the trees. So if I come into the first non-linear data structure, that is tree, as the definition says, collections of the root nodes and the subnodes. Collections of the root nodes and the subnodes. So this is what we call as tree. See, in the tree, some definitions will come. What is root node? What is root node? Root node is a type of the node which contains the minimum two subnodes. And in root node, there is no connected by other nodes. There is no connections with the other nodes. The A will be the root node. See, A will be the root node, and G, H, and like that for I will be that is leaf nodes. Leaf node means there is no connection, there is no nodes connected for these kinds of the node. The types of the nodes are terminal nodes. Terminal nodes means that nodes are ended. So that is what we call as leaf node. And root node is the main node containing minimum two subnodes. And what are subnodes? Subnodes which are connected by the root node and it has minimum two again subnodes. That is also called as a binary node or a binary tree. Minimum two subnodes. Here B and C will be the binary nodes are acting. So this was some definitions of the trees: root node, leaf node, and also height of the node. Height of the tree. See, height of the tree and depth of the tree. Two different definitions. So height of the tree from the leaf node to root node. From the leaf node to root node, what will be the height? So this will be total number of the nodes are connected in between root to leaf. That is what we called as height of the node. And like that same depth of the tree from root to leaf node, what will be the contents of node, number of the nodes will be connected. That is what we called as depth of the tree. Height of the tree, depth of the tree, root node, leaf node, angle of the trees. Angle of the trees is what we called as total number of the elements are connected in the tree. So that is what we called as angle of the tree. So these are all the some definitions will come for the tree. Like that, another one, last data structure, that is graph. So graph is also a collection of edges and vertices. Vertices and edges are connected, that are what we called as graph. But dear students, one thing you remember, in the graph we have the two categories. One is directional graph, second one is undirectional graph. This is a graph is undirectional. The same diagram, the same graph, if it is a movement, if we are showing the movement flow, then the graph will becomes the directed graph. So this is the definition for a graph, and whatever edges and vertices. See here, A, B, C, D, E and F. A, B, C, G, E and F are acting as edges, and vertices A to B, B to C, C to D, D to A, D to E and D to F are the vertices of the graph. So these are all what we call as non-linear data structure, trees and graph. If you know the definitions of non-linear data structure with a graphical representation and some definition, that's more than enough for the non-linear data structure. Dear students, by this topic we are concluding the data structure chapter, very important for your examination and also for lab examination, because based on this chapter only you will get more programs for lab and also very detailed theory that is for the data structures. So keep practicing by writing the keynotes, and we will send some questions with answers for the data structure. Keep practicing on that. If you have any doubts regarding data structures, please contact me through the WhatsApp and submit your notes within a time. Thank you.